Hey guys, welcome back. This will be the last video of the Redux series, and again, the aim is to keep it short, but clearly I have not quite succeeded so far. Uh, let's go. This is the state of our application. These buttons work as expected. I think this should work too. This works as expected too, so that is fine. But this button doesn't work, and we'll get this button working. Now, before we get this working, one principle that we have to agree upon is every time. Oh crap, why did I minimize it? I want to toggle it. The principle that we want to abide by is every time a button is clicked, we want to dispatch an action. Look at line 37 for an example, or look at line 26 for an example, or look at line 20 for an example. Every time a button is clicked, we want to dispatch an action. Right? That is understood. So let's dispatch an action. We'll call this async increment, and we'll send in a payload, and this will be increment value. Async increment has not been created yet, so we will do that over here. We imported it, but we never quite created it, so let's fix that by doing something like this: async increment state action set timeout dot. We want to update the value of state. Is this it? I think this is it. Oh, we have to export the action, right? Async increment. Async increment. Okay. Let's hope this works. Add value 2, add value. There you go. We have a problem. Cannot perform get on a proxy that has been revoked. Look, I can't make heads or tails of this particular error message, but having read through the documentation, I know something. You're not allowed to call. Oops, wait. There's a second thing that I forgot. Let's give it a fair shot before whipping out the documentation. Come on, where's my... Oh, I minimized it again. Sorry, guys. Okay, let's refresh. Let's set a value of 2, add value. There you go. Cannot perform get on a proxy that has been revoked. Again, I can't make heads or tails of this, but having read through the documentation a bit, I know that you're not allowed to call set timeout inside a reducer. The purpose of a reducer is to take the old state, take the action, return the new state. No extra processing to be done. No waiting operations inside the reducer. So what's the workaround? I think there is a workaround. Remember, we have to obey 2 rules. In fact, let's write a page document for this. The 2 rules to be, where is my mouse? Create a new document, blank. The new rules to be followed are: when an event fires, for example, a button click event, we should dispatch an action. We met that rule, so no problem. Next, when there should be no waiting / async operations inside the reducer. Okay. No, I don't want to do anything about this. I don't want to save this file. Okay, let's make it big. Okay, these are the 2 rules that we have to follow. We follow the first rule, so let's try to follow the second rule now. How do we follow the second rule? Well, there is a little method that has been exposed for us. We'll call this we'll continue calling this async increment, and we will do something like this. async increment equal to this particular callback will return another function, right? Async increment accepts one parameter, which is the action, and it returns another function. The function it returns accepts a parameter called dispatch. Dispatch itself is another function. I know it's getting a bit complicated. And we will call dispatch with the argument action inside a timeout. Dispatch action 1000. Why is this complaining? Has already been declared. Where? It got declared over here. This should settle it. The reason this video was made independently from the previous video is because I want to drive home that this particular function definition pattern is in fact what is expected should you ever encounter situations where you're working with asynchronous operations. You have to follow this coding pattern wherein you pass in, you define a function where action is passed in as a parameter, and the return value is a callback that itself accepts dispatch as one of its arguments, right? I know this sounds a little complicated, but the good thing is it's the sort of boilerplate that you can reuse in other instances where you're working with asynchronous operations. It doesn't have to be just set timeout. I can always do something like, assuming I was using the Axios library, I can do something like axios.get a random URL, and then I can do something like then success result whatever, and then I can do dispatch success result, right? This is a very acceptable thing to do. In fact, this is the reason why this particular pattern has been exposed is so that you deal with asynchronous operations like AJAX requests. So Redux does work seamlessly with asynchronous operations. That's the idea of this coding pattern. Surely you can find this in the Redux template that's provided should you create a React app using the Redux template. So you don't have to make any special notes of this, but I'm pointing it out because this is the only way you can perform asynchronous operations if you're using Redux. And that is it. That's the last video of the series. Sorry, this is a little longer than I'd have liked it to be, but hopefully it added some value to you if you watch the entire series, and I look forward to making more video series in the future. Take care.